So these are the doubts from assignment, chemical energetics and enthalpy change. The first one is 980. 90. Values of the boiling temperature and the standard enthalpy change of combustion of series of straight chain alkanes are shown here in the table. Explain why the increase in the value is similar. What is the reason why the values which are increasing, they're increasing in a similar manner or a similar pattern? Because when you check the difference between the bonds or which bonds are different. So example, if we draw C2H6, which is ethane, so 2 carbon and 3 hydrogen on one and then 3 hydrogen on the other. This is ethane. When we draw C3H8, which is propane, then we draw C4H10, which is butane. So when we find the difference in the bond for between ethane and propane and butane, we'll find the same bond differences there. Like example, this contains 2 carbon, like carbon-carbon single bond and 3 CH, 6 CH bonds are there. This contains, like, what are the extra bonds increased? CC bond is already there, so one of the bond is extra. Like this one example, I said this is the extra CC bond. This is extra CC bond. This is already there, and 2 of them hydrogen. So 2 CH bonds are added like extra, and 1 CC bond extra. When we check for this one, so 2 CC bonds are extra, and 4 CH bonds are extra. So means it increases in the same manner, same pattern. Like example, the number of the bonds which are changing in each. So answer for this question is, because like each member is differ by CH2. This was C2H6, this is C3H8, this is C4 and H10. So what is the difference between them? Like 1 carbon and 2 hydrogen difference. What is the difference between them? 1 carbon and 2 hydrogen difference between them. So one carbon and 2 hydrogen difference, so they have the same difference. As they have the same difference, it means they have the same bond difference as well. Like the number of the bond. When I compare ethane with propane, if you see ethane with propane, so it has 2 CH bonds and 1 CC bond. Now when I compare propane with butane, so this is having 2 CC bonds, this is having 3 CC bonds. So again, one is extra CC bond, and when we compare, this is having 1, 2, 3, 4, 5, 6, 7, 8 bonds, and this is having 12 CH bonds. So again, the extra, like 1 CC bond is extra and 2 CH bonds are extra. Same thing, one compared to ethane and propane, 1 CC bond is extra and 2 CH bonds are extra. That's why they have the same difference in the bonds or same difference in the number of atoms. That's the reason they have the similar enthalpy change or the difference. Like the difference from 1500 to 22 about 700 is there. This is also about 700, not exactly, but about 700. Same thing, this is also about 700, about 700, about 700. So what is the reason? Because each member differ by the same number of atoms, or difference between each member is same CH2, or the number of the bond. Like if this is having 1 C bond and 6 CH bonds, this is having 2 CC bonds and 8 CH bonds. So the difference is same in terms of bond. And the next part, the increase in the value of enthalpy change of a combustion from butane to pentane is smaller than other increase. We have to suggest an explanation. So when we compare butane to pentane, that difference is smaller, but rest other difference are approximately same, like as the difference are mentioned. So what is the reason for that? Enthalpy change of a combustion also depends on the initial state of a substance. As we know, first four members of alkane are gases. Like here we are burning gas. Then we are burning liquid. So first, even when we are burning a liquid, liquid vaporize and then burn. That's why some of the energy is used to vaporize and then burn. So first four members of alkanes are gas, like methane, ethane, propane, and butane. And then after that, they are liquid. So enthalpy change of a combustion for a gas is different as compared to liquid. That's why they don't follow the similar trend. It is slightly smaller. What is the reason why slightly smaller value? Because the energy is used first to vaporize and then to burn it. And then the enthalpy change, like energy is released when substance is burned, that energy is absorbed by the fuel and it will vaporize most of the particles. Is it clear? Question 9 part B. Yes, any doubt in this? Question 9 part B.
Can you repeat once more, like why? For
What is
part B?
Part B, they are asking why for butane, like for other, the difference is about 259, 258, 254, 254, but this is 632. The reason is that here the first three are gases. Like basically first four are gases, but methane is not shown here. So this one is a gas, this one is a gas, this one is also a gas. Then we have liquid, liquid, liquid. Now, when we move from butane to propane, enthalpy change of a combustion is not same. Why the enthalpy change of a combustion is not same? It is slightly smaller. Because what happened when we burn pentane, pentane is a liquid. So when we are burning a pentane, it releases energy because the combustion reactions are exothermic, so it releases energy. As a result, when this energy is released, burning, that energy is absorbed by the liquid. Some of the energy. So if some of the energy is absorbed by the liquid, will not receive the same amount of energy, will receive slightly smaller amount of energy. That's why the difference between a butane and pentane is slightly lower as compared to other values. But when we are burning a gas, so when we are burning a gas, that time already all the particles are in a gaseous state, so these particles cannot absorb too much energy. So maximum amount of energy will receive. That's why it is 658, a higher value when we are burning a gas as compared to when we are burning a liquid. Liquid absorb energy. When the liquid absorb energy, that energy is used to vaporize the or convert the liquid into a gaseous state. Is it clear?
Yes.
Then question 10, the energy profile diagram for the reaction is shown. What is the maximum energy need for this reaction to occur? Like basically the activation energy. What is the activation energy? Energy from reactant till the point where the reaction start is called activation energy. So this is the amount of energy which we need to start up this reaction. So which one is this? This matches with letter next. And what is the enthalpy change? If the question is enthalpy change is the arrow which we draw from reactant to the product. So it will be total X minus Y. So X minus Y will be the enthalpy change, but X is the activation energy, minimum possible energy to start up a reaction. Next is question 12. The enthalpy change of two reactions are shown. What is the enthalpy change for dissociation of methanoic acid to methanoate ion plus hydrogen? So how we can work out this? Like if using is or solving at the simultaneous equation. So this is the first equation, this is the second equation. What we want a dissociation from methanoic acid. Like we want methanoic acid, sorry, ethanoic acid, not methanoic, two carbon are there. So ethanoic acid to ethanoic and hydrogen ion. This is what we want. So as you can see, we want to remove this OH in water. OH both on the left hand side, and if you want to cancel out the similar reagents or ions which are on the same side, so we subtract the two equations. Because they are on the same side, so we want their sign to be changed. That's why we subtract the two equations. So if I write equation 2 first, like CH3 COOH plus OH gives CH3 COO and H2O, and the enthalpy change is minus 56. Use this space, so we have ethanoic acid CH3COH plus OH gives CH3COO plus H2O, and then enthalpy change is equals to minus 56. And then H plus OH minus gives H2O, and then enthalpy change is minus 7.2. What we don't want OH. So we should, even you can subtract equation 1 from 2 or 2 from 1, it does not make difference. So we subtract the two equations, this will be minus, this will be minus, this will be minus, and this will become plus. Why? Because the sign changes. So OH will cancel with OH. The OH ions will cancel out each other, and water also cancel out each other. So what we are left with? We are left with CH3 COOH minus H plus ion gives CH3 COO, and when we simplify, it is plus 57.2 and minus. So this will come out as 1.2 because and positive. But this H is negative, so this H will go other side. When we move to other side, this will become H plus. So this is the dissociation of ethanoic acid CH3COH to ethanoate ion plus hydrogen ion, and the enthalpy change will come out as plus 1.2. So in that case, for question 12B will be the right answer. Is it clear? So when two equations are given, you can use the concept of simultaneous equation and cancel out the common ion which you don't want in the final answer. If they are on the same side, you subtract the two equation. If they are on the opposite side, like one of the ion was example on the right hand side and other on the left, in that case I will add the two equations, so they will cancel out. So it's like a simultaneous equation. Is it clear? For example, you subtract the for the second equation from the first. So if it is minus here, this will be minus, this will be minus, this will be minus, and this will be plus. So OH will cancel with OH, water will cancel with water. What we are left with? We are left with H plus and minus CH3COH, ethanoic acid, and that is minus CH3CO, and the final answer is minus 1.2, because when you solve, it will be minus 1.2. If because this is negative, so this will move other side, and molecule of ethanoic acid moves. It's on the left hand side negative, so right hand side will be positive. So H plus CH3CO gives CH3 COH. And the enthalpy change is 1.2 or minus 1 point. We don't have to change sign right now because this is negative, so it will move other side become positive, and this is negative, move other side become positive. But in the question, we don't want this answer. What we want dissociation of ethanoic acid. We want this when ethanoic acid dissociate into ion, ethanoate ion, and hydrogen ion. What is enthalpy change? But this is opposite. Here ions combine to form ethanoic acid. So if ions combine to form ethanoic acid is minus 1.2. If I completely change the equation, like if I write opposite ethanoic acid molecule dissociate into ethanoate ion plus hydrogen ion, so enthalpy change will be 1.2. Why I completely split? Because I completely change the equation, that's why the enthalpy change will also become opposite. Because when ions form a molecule, it was minus 1.2. But if the molecule form an ion, it will be plus 1.2. Because if the forward reaction is exothermic, backward reaction will be endothermic. So again, we'll get the same answer, which is 1 point. Is it clear now?
Yes.
The next question number 16. When 10 cm cube of a nitric acid react with 20 cm cube of a sodium hydroxide, the temperature change is delta T. When we repeat with 15 cm cube of the same nitric acid and 30 cm cube of sodium hydroxide, solution would give a temperature rise to. So look, the temperature depends on two things: how many moles are used and what is the total volume of the solution used for the experiment. So first, if you write the limit, and if we consider, like example, we have a reaction between nitric acid, which is HNO3, and sodium hydroxide, NaOH. So the balance equation, that 1 mole of sodium hydroxide react with 1 mole of a nitric acid gives sodium nitrate plus water, H2. So 1:1 is the ratio between them. Now, when we are using 10 cm cube of nitric acid, 10 cm cube of nitric acid is this one, HNO3. And we are using 20 cm cube of sodium hydroxide. So which one is a limiting reagent? The limiting reagent is nitric acid, because if we have the same concentration, two solutions are having the same concentration. So the one which is in a smaller amount, it will be a limiting reagent, as the ratio between them is 1:1. So nitric acid is a limiting reagent. And enthalpy change, we have the formula E is equals to Cf delta T. So temperature change E divided by Cm is equals to delta T. So energy change, the temperature change is proportional to the number of the moles or energy release, and it is inversely proportional to mass or the volume of solution. So when we repeat the experiment with 15 cm cube of a nitric acid, and we use 30 cm cube of sodium hydroxide. So again, sodium hydroxide is an excess, nitric acid is a limiting. So first, for the change in amount, like this, when we compare the number of the moles, so what is the change in the volume? 10 becomes 15, so means it is multiplied by 1.5. So energy and temperature change are directly proportional. If the number of the moles, like this, compared to 10 cm cube, 15 cm cube contain 1.5 times more moles. So if the mole become 1.5 times, the temperature change will also increase by 1.5. If this is increased by 1.5, this will also be 1.5. But then what about the total volume? What is the relation between temperature change and the mass? That is inversely proportional. So what is the total volume of the solution? Total volume of the solution is 30. Means total mass is 30 because we consider the density of a solution is 1 gram per centimeter cube. Here the total volume of the solution is 45. So the total volume, what happened to total mass? 30 becomes 45. It means it is also multiplied by 1.5. So this is multiplied by 1.5. This will be divided by 1.5 because they have an inverse relation. So due to change in amount of nitric acid, it is multiplied by 1.5, and due to change in amount of the total mass or the volume of a solution, it is divided by 1.5. So what is the overall temperature change? The overall temperature change will be same as the initial one. So like if initially the temperature change is delta T, the final temperature change, if we use 15 cm cube of nitric acid and 30 cm cube of sodium hydroxide, it will be same. So it won't make a difference. Is it clear? Yes. So one is the change in amount of a limiting reagent and the other one is the total volume of a solution. Both have the effect on the temperature change. And next we have ISO 1627. A similar type of a question. When 10 cm cube of 2 mole per dm cube hydrochloric acid react with 10 cm cube 2 mole per dm cube of sodium hydroxide, the temperature change is delta T, and here the equation is given. When the reaction is repeated with 50 cm cube of each solution. So first, because we are using the same amount, so both of them will be, as the ratio between them is 1:1, and we are using the same amount of same concentration, so both of them will be used up. Like I can take any of them. So HCl, if I'm taking example HCl, so how many moles will be there? The concentration is 2 and the volume is 10 divided by 1000. So this will be 0.02. So in the beginning we have 0.02 moles of HCl. And then if we use 50-50 for both will be used up. But if I'm taking only HCl moles in 50 cm cube, so it will be 50 divided by 1000 and multiplied by multiplied by 2. So that is 0.1. So we are using 0.1. So by what factor the moles change for one of them, that is changed by factor 5. Like because 0.1 multiplied by 5, that will be 0.1. And what about the total volume? Because first we use 10 and 10. So the total volume of the solution was 20 cm cube, or I can also say 20 gram. Because we consider moles, the density 1 gram per centimeter cube. After that, we change to 50-50, that makes 100 cm cube. So 100 cm cube means 100 grams. So by what factor the mass of the solution changes? 20 becomes 100. So that is also factor 5. So we know the formula E equals Cm delta T, or E divided by Cm equals to delta T. Means energy or the moles are directly proportional to temperature change. So if the moles are multiplied by factor 5, the temperature change will also multiplied by factor 5. And what is the relation between mass and temperature change? It is inverse. If the mass of a solution increased by factor 5, the temperature change will decrease by factor 5. So one is, in one case the temperature change is multiplied by 5, The other case, it is divided by 5. So what will be the overall change? The same idea. So because of change in moles, it is multiplied by 5. And because of change in mass, it is divided by 5. So what is the temperature change? It will be delta T, or A will be the right answer. Is it clear, this one? That why the temperature change is same? Why it is multiplied by 5? As you can see here, the number of the moles, when you check the number of moles for any one, because here we can take any of them as both of the substances are used up. So first, in the beginning, when we were having 10 cm cube, 2 mole per dm cube, the moles were 0.02. Then we used 50 cm cube of each solution. So 50 cm cube of each solution means contains 0.1 moles. So by what factor the mole changes? So mole changes by factor 5, by multiply by 5. And we know the relation between energy and mole or temperature change, they are directly proportional. So if the moles are multiplied by 5 or energy is multiplied by 5, temperature change will be 5 times. But what about the mass and temperature change? It is inverse. So in the beginning, the total volume or the mass of a solution 10 plus 10, it was 20. Then we use 50 cm cube of each, 50 plus 50, that is 100. So if the mass increased by factor 5, or because there is an inverse relation, so temperature change will decrease by factor 5. So in one case, the temperature multiplied by 5, the other one divided by 5. That's why the overall temperature change will be A. Volume of the solution. Next is question 28. In which experiment to measure the enthalpy change of a reaction involving gases, which of the following condition must always kept constant? So when we are measuring the enthalpy change of a gas, what factor, like, because the pressure can affect both volume and temperature. So we have the formula enthalpy change is equals to Cm delta T. So what we should keep constant here, what condition should be kept constant? The pressure on the gas should be kept constant, because pressure can affect the volume, pressure can also affect the temperature. So pressure is a factor which must be kept constant. So we should keep the gas at a constant pressure and find the enthalpy change involving gases only. So this is a condition which you have to learn. Then we have 55C1. Copper sulfate hydrated, which is in a solid state, dissolved, the enthalpy change is 11.5. Describe briefly an experimental procedure that you would use to obtain data necessary to calculate ΔH1, like enthalpy, like how much energy is absorbed when hydrated copper sulfate dissolved. You should state the operators that you use to measure and how we work out this. So we want to calculate the enthalpy change when hydrated copper sulfate dissolved. So we have the formula E is equals to Cm delta T, where C is a specific heat, M is the mass of a solution, or we can also say the volume of a solution, and delta T is the change in temperature. How much temperature change? That is delta T. So practically, how we can work out? So we have this E equals Cm delta T. and we want to calculate enthalpy change. Enthalpy change or ΔH is basically the energy which is released divided by number of the moles. First, how to get the moles? We have the measured mass of a hydrated copper sulfate, like we have a hydrated or a solid copper sulfate. Using a balance, we'll measure the mass. We'll use a balance to get the mass in gram. And mass in gram divided by molar mass, what we'll get the mole. So we have one of the factor. Now we need E. How to get E? E equals Cm delta T, where C is the specific heat of a water which is 4.12 or 4.17 or 4.18 or 2. M is a mass. What about the mass? So we'll use a measuring cylinder and fill up this calorimeter or a container will fill. So by using the measuring cylinder, we'll measure the volume, and volume will be equal to the mass, because we consider that the density is 1 gram per centimeter cube. So mass of a solution is same as the volume. So we'll get the mass also by measuring the volume. And how to get the temperature? So we'll add copper sulfate, because we want to find when solid hydrated copper sulfate dissolve and become aqueous. So we'll place a thermometer. Using a thermometer, we'll measure the initial temperature, that is T1. And then we will add hydrated copper sulfate, which is in a solid state, and dissolve, stir and dissolve. And then we'll measure the final temperature. So using a final temperature, we'll find the temperature change, that will be T2 minus T1. So we have the temperature change, we have the mass, and we have specific heat. So we'll find the energy. And energy divided by mole, what we'll get? We'll get the enthalpy change of this reaction. Is it clear how we work out enthalpy change for dissolving hydrated copper sulfate? Okay. Then question 60 part A. Define the term enthalpy change of a reaction. Like for some reaction, enthalpy change cannot be determined. What is the definition of enthalpy change of a reaction? It is amount of energy which is absorbed or released when 1 mole of a reactant form a product. So that is refers to enthalpy change of a reaction. Like enthalpy change is when you can mention one mole of a substance or 1 mole of a product is formed or 1 mole of a reactant is formed, or enthalpy change when the number of moles of a product or a substance are formed. But this is not standard, so we don't have to use 1 mole. We can use, because here they only ask for enthalpy change of a reaction. So enthalpy change of a reaction, it is amount of energy released or absorbed when a reactant form a product according to the balance equation. So energy released or energy absorbed or energy change when reactant form a product without so when reactant form a product with according to balanced chemical equation. When the equation, the chemical equation is balanced and reactants are forming a product, we call that as enthalpy change of the reaction. So these are the questions from assignment chemical energetics and bond enthalpy.